Welcome, ladies and gentlemen. So what I'd like to do is show you how to find the slant, or called the oblique asymptotes of a rational function. Now, the slant asymptotes of a rational function occur when the degree in the denominator is smaller than the degree in the numerator. And what this tells us is we can actually divide the denominator into the numerator, and the quotient, the answer of that division, is going to be our slant asymptote. So when we're looking at these problems, what we basically want to see is how we can divide them. And in the first example, we can see that we have x squared minus 5x minus 36 being divided by x. Now, this one's a kind of a little special case because you see that my denominator is a monomial. So basically what that means is I can divide each and every one of these terms by x. So that's exactly what I'm going to do to start off. So I'll have an x squared divided by x minus 5x divided by x minus 36 over x. When I go ahead and simplify this, my quotient is going to be x minus 5. And I cannot divide x into 36, so I'm just going to leave that as a negative 36 over x. However, if we were to graph this, if we were going to graph this quotient, what we would understand is the graph y equals x minus 5 minus 36 over x is very similar to what just the equation y equals x minus 5 would look like. Similar, except at 0. That's where it kind of gets a little funky. And the reason being here is this graph, as we continue as we keep on entering in larger and larger numbers for x, or really, really, really small numbers for x, like negative 1,000, negative 1,000,000, what we see is 36 over a really, really large number really goes to 0. So what's happening is the oblique asymptote is really just going to take the shape of y equals x minus 5, the quotient, and not really deal with what's left as the remainder. So when you have a rational function with a monomial in the denominator, this is the easiest way to basically find the quotient. However, there are going to be problems where you're going to have to use long division, and I'll explain when we get to those problems. And a lot of students struggle with the long division algorithm, so I am going to also solve this problem using long division just to kind of practice up our skills. So if we're going to represent this with long division, I'm going to set it up for the long division algorithm. I'm going to take my divisor, put it outside, and then I'm going to put my dividend inside. Then, basically, we're just going to take my value of x and say, how many times does x divide into x squared? That's x times. Now, we can always check our work, because when I take my quotient, multiply it back, I should get the exact same expression. Now what we're going to do is subtract our rows. Now, there's only one term here in our row, and there's nothing else here. You can kind of use place values if you want to, but I'll show you in more other examples when place values are a little bit more helpful. You also don't need to use parentheses, but you'll see later again why the use of parentheses can make a very big difference. So x squared minus x squared is then just going to be 0x squared, which is just 0. Now I could subtract 0, or I could just, sometimes we say just bring down the next terms. And now I say x divides into negative 5x, negative 5 times. Negative 5 times x is negative 5x. Again, they're exactly the same. That's good. Subtract my rows. And again, I get 0. Bring down my negative 36, or say subtract 36 from 0. X does not divide into negative 36, so what we'd say is, hey, that's like your remainder, right? And that is my remainder, but we could also write a remainder as our quotient. So we'd say plus negative 36 divided by my divisor, which is x. And you guys can see this is the exact same answer I got. Obviously, this is the quicker method, but I wanted to show you long division because every single problem I'm going to be doing long division, and sometimes it gets a little bit more confusing. So I wanted to do a basic problem where we could quickly and easily check our answer. All right, so let's move into the next one. Now, the next problem, we see that, again, the degree in the denominator is smaller than the degree in the numerator. But this one is not a monomial. It's a binomial, x minus 4. So we can't apply dividing it into each and every one of these terms, at least, and being able to simplify like we did before. Because that one was, we could just simplify using the rules of exponents. If we were to distribute that, we wouldn't be able to simplify it in the same manner. So again, let's go ahead and just use our long division algorithm. So now I'm going to set my divisor x minus 4 and my dividend x squared minus 5x plus 6. So now when you have a divisor, it's really important. I didn't mention this in the first problem, but it's really important when you're using long division to make sure that they're in standard form with descending powers. Basically, your first term is your leading coefficient, and your degree means it has the power. Your exponent is to the highest, so I want to make sure your dividend is an ascending power as well as your divisor. Now, when I take x and divide into x squared, I get x. Again, so you only are going to take the first term when you're doing long division with a divisor that's more than one term. So you're only going to use the first term. But when you take your quotient, you got to make sure you multiply it times each one of these terms. So x times x is x squared. X times negative 4 is negative 4x. Now the parentheses are really, really important. I got to make sure that I'm subtracting the whole row. So it's x squared minus x squared, which again is just going to be 0. Negative 5x minus a negative 4x. So minus and negative is the same thing as like adding. So adding, so therefore that just becomes a negative x. You could say 6 minus 0 if you like to, or you could also use the just kind of bring it down function. Okay, now we go ahead and go through the algorithm again. X divides into negative 1, negative x, negative 1 times. Negative 1 times x is negative x. Negative 1 times negative 4 is going to be a positive 4. Now again, I subtract my rows. Negative x minus negative x is again going to 0. And then 6 minus 4 is 2. Now, again, that 2 is going to be a remainder. So what we learned is, yes, we could write it in there if we wanted to, the remainder over your divisor. But we don't care so much about that as when we're finding the slant or the oblique asymptotes. We just want to know what the quotient is. So again, remember, it is a line. So we're going to write this as y equals x minus 1. That is my slant asymptote. And I'm just going to alternate slant and oblique. So therefore, that is my asymptote. Now, in an example like this, we actually can also use synthetic division. We don't have to use long division. So synthetic division is just another way to divide. But we can only use synthetic division when our divisor is linear. That means it's x to the first power minus some number or plus some number. So we can only use it when it's raised to that power. But when we do have it, it's to apply synthetic division. Basically, what we're going to do is you could say this divisor, we need to be able to, we can say this is a factor of the polynomial. So what we'll need to do is set it equal to 0 to solve. Now, a lot of people say, well, why set it equal to 0? Because I can just easily say it's the opposite value, right? But a lot of times, people will make mistakes when they throw in a 3 there, and they'll say it's still 4. No, now it's going to be 4/3. You'd have to divide by 3. So just a small little thing. This isn't a video on synthetic division, but just something to kind of be aware of. So now what we're going to do is we're going to take the 4 on the outside, and we're going to take the coefficients of each and every one of my terms. So we're going to take a 1, negative 5, and a 6. And it's important just to remember for synthetic division to also make sure it's in descending power, and as well as if you have any missing terms, if you had like a gap in your polynomial, just to make sure you use the coefficient as 0. But again, that's for another video. So to do synthetic division, you just take the first number, bring it down as 1. So you always bring down the first one, then you multiply the diagonals. 1 times 4 is 4. You add the verticals. Negative 5 plus 4 is negative 1. Negative 1 times 4 is negative 4. 6 plus negative 4 is 2. And again, synthetic division is not pure division like long division, but it does kind of give you the coefficients of your quotient polynomial a little bit quicker. The last term is always your remainder. The next term is going to be your constant. And then this is the coefficient of your linear term. So y equals x minus 1. And again, that is going to be the same answer I have here. Let's just write the remainder. That's how we write the remainder as far as in a long division, or as a I can't remember this thing. But again, we don't need the remainder. All we need is y equals x minus 1, or as a divisional statement. There we go. All right, so in the next one, we notice that we have a 3 minus x squared, but it's squared. So again, it can't use synthetic division because the divisor is raised to a power other than 1. And we can't simplify it using like the rules of exponents because it's a binomial. So the first thing we'll want to do is set up our long division. We'll want to make sure it's in descending form. So I want to rewrite this as negative x squared plus 3. I'm just switching those around. And then I'll set up my long division. So negative x squared plus 3 dividing into 3x cubed minus 8. OK, so again, just like I did over here, you're only going to take your first term and divide it into the first term of your dividend. So negative x squared divides into 3x cubed how many times? Now this time we have a little coefficient. So you're basically saying negative 1 divides into negative 3 how many times? And again, we want to make sure that we get the exact same answer as we go back. So that's going to be negative 3x. We can always check our answer because we multiply our quotient times each of these terms. So negative 3x times negative 3x squared is going to be a 3x cubed. Negative 3x times 3 is going to be a negative 9x. Now, a lot of times this comes into a little bit of problem because people are like, uh-oh, like how do I subtract? I can't subtract 8 from 9x because they're not like terms. So what we can do is move this negative 8 over and add a positive 0x. And that positive 0x is basically just acting as a place value. You don't need it. And the more comfortable you get with long division or just number sense, you don't have to include that. But I think a lot of times when people are learning this, it's just kind of helpful to include it. So now we subtract our rows. 3x cubed minus 3x cubed is going to be 0. Notice how that's the same pattern. We want to get that every single time. So if you don't get that, either check your math or check exactly what you did to make sure, because they should be exactly the same. So then we do 0 minus a negative 9x. Again, 0 minus a negative 9x is now going to be a positive 9x. And then we could do 0, negative 8 minus 0, or you can just bring it down. But again, it doesn't really matter because negative x squared does not divide into 9x, right? So you have to have the powers smaller to divide into that. So therefore, that is now my new remainder. But again, we don't need that to be, we don't care really about our remainder. Our asymptote line is y equals negative 3x. And that's it. Done. All right, so on the next example, again, we can't use synthetic division. So just because that's easy doesn't mean we can I'll use it every time. It has to be a linear binomial. And then over here, we can't use that. So we're going to have to set up our long division. So again, I'll take my divisor, put it on the outside, and then take my dividend, put it under. OK, so x squared divides into x cubed. Again, it's really saying 1 divides into 1/2, and we can just say 1/2 times x. And again, we can always just check our answer. 1/2 x times x squared is 1/2 x cubed. Those are exactly the same. Good. 1/2 x times negative 4 is going to be a negative 2x. But again, we can't subtract 2x squared from negative 2x. So what I'll do is I'll just move that over. I'll just put a 0x squared there and put a negative 2x over here. So now I subtract my rows, put these in parentheses. We don't have anything for the x, so I can just add a positive 0x right there. So 1/2 x cubed minus 1/2 x cubed is going to be 0 again. 0x cubed, which is 0. Sorry. 2x squared minus 0x squared is obviously just going to be 2x squared. And then 0x minus a negative 2x is now going to be a positive 4x. So now we do, just like we did in this example, we just do the algorithm all over again. X squared divides into 2x squared 2 times. 2 times x squared is 2x squared. 2 times negative 4 is going to be a negative 8. I'll just bring this over here. And I'm just going to bring this one down. So when I subtract, that goes to 0. That's really subtracting 0, so it's a 4x. And then that's 0 minus a negative 8, so that's going to be plus 8. Say that's plus 0. But again, I kind of knew this. I didn't really care as much what those were because we're not really doing long division. I'm just asking what is the asymptote. So since x squared does not go into 4x, I know my final asymptote, oblique asymptote, is 1/2 x plus 2. So there you go, ladies and gentlemen. That is how you find the slant, or also called oblique asymptotes of rational functions. Thanks.